Assalamualaikum and hi everyone. For today's video, we from group 2 will present to you guys chemistry case study number 1, which is de-icing of applants. Before we start, let me introduce you our group members. First, Putri Nur Aidis Adriana binti Syamsul Azri. Number 2 is Dayang Nurul Iza binti Aung Jeman. Next is Nur Shazia Auni binti Malim. And lastly me, Nur Intan Syama binti Haris. De-icing of a plant is a process of removal, and the second step, which is anti-icing, is prevention of build-up of snow and ice. De-icing a plant usually done when snow, ice or frost amass in the aircraft, so the pilot will call the de-icing facility team at the airport to remove the ice. The de-icing a plant usually will be done on the wings and rear tails, as the snow or ice could disturb the airflow and become a crisis during takeoff. It is done on the nose of airplanes, where the radar equipment is placed to make sure that the radar would be able to work properly. The icing of airplanes is very important because the build-up of snow or ice on the wings or rear tails can cause the crash of airplanes. It is because they interrupt the airflow across the surface. Wings and rear tails are engineered in a specific shape in order to provide a proper lift-off. These parts of a plane will undergo changes in shape and addition of weight if snow or ice precipitate on these parts. As for example, Air Florida Flight 90 was failed to gain altitude during takeoff. Later then, the airplane was stalled before hitting a bridge and crashed into the Potomac River. It happens on January 13, 1982, shortly after taking off from Washington National Airport. The pilot error became the official cause because they failed to turn on the engine's internal ice protection system.
Hi everyone, my name is Putri Nur Aidis Adriana binti Syamsul Azri and my student ID is 2020868146. Why planes need to be de-iced? This is very crucial and very vital in order for the plane to safely take off and having a low risk of any catastrophic accident to occur. Why? We already know that de-icing fluid will help in removing, also preventing any build-up of snow, ice or frost that might stick to the wings, tails or any part of the airplane. Plus, this also can be very closely related with the concept of aerodynamics. We already know that this is the wings. Where there is airflow above and below the wings, it will create a lift. With that, the wing surfaces need to be very smooth in order to work optimally and also very safely. This is very crucial as slight changes in the wing surfaces, it will change the shape and the texture of it. When this happens, the wing will disrupt the airflow and loses the significant amount of lift due to the air has trouble and sticking to the wing surfaces. When this happens, the air will separate and will create a turbulence. In this case, if involved with frost, then it will change the texture of the wing and it will become much more rougher, as like a sandpaper taster. But if it involved with snow, it will change the aerodynamic shape of the wings fully, which is very something that we won't want to be happening in order for the plane to safely work optimally. And this time I'm going to share with you guys about the advantages and disadvantages of de-icing equipment, which we have 5 of them, which is pneumatic de-ice boot, whipping wings, bleed air, heated surfaces, electrically heated surfaces, and last but not least is electromechanical, also known as EMEDS. So let's start with the first one, which is the pneumatic de-ice boots. The advantages of this is uses compressor bleed air, which is never run out of de-icing protection. It has manual and also automatic modes, which this is very efficient for ice removal. But the disadvantages of this is when inflating the boots, the aerodynamic characteristic of the airflow surfaces changes. Also can increase the stalling speed, also having high risk of ice accumulation behind the boot and risk of holes in the boot. Second is the whipping wings, which is it can protect entire airfoil surface. TKS fluid pump up and rounds back across the top and the bottom of the surface to form a layer of protection against ice. But the down part of this is there's only limited amount of TKS, so it might also eventually run out. So we need to consider whether actions to use it or not. Third is bleed air heated surface. This is very efficient as long as the engine is running. The bleed air located in the turbine will be hot enough to prevent ice formation. But this device needs to turn the system right on time. If the timing is wrong, there might risk for run back. It could also freeze off or protected surfaces, and maybe chunks of ice could break off the engine coil and get ingested into the engine. For the fourth is electrical heated surfaces. It could be provided with de-ice and anti-ice regardless of engine operation, unless there is electrical failure to it. But the black part of this can be damaged if the heating device is left on during ground operation. So it also have inability to heat large areas such as the wings and the tails. Last but not least is the electromechanical, also known as EMEDS. The advantages of this, which is it can detect ice by sensor. When ice accumulate, coil behind the leading edge skin starts to vibrate, causing the ice to break off, and the system doesn't increase stall speed, but relatively low power requirement needed for operation to occur. But the down part of this, it must be built into the airframe. Therefore, it can only develop into smaller aircraft as applicability on all surfaces.
Now I will present about how aircraft de-icing works. Critical surfaces on an airplane such as wings, control surfaces like slats, flaps, horizontal and vertical stabilizers, ailerons, it must be free from any contamination. Firstly, we will do outside check as it is mandatory because the contamination could have damaged sensitive instruments just like pitot tubes, angle of attack instruments, and also static parts. Once we have completed the outside check and notified the pilot about the contaminated wings, now it's time for us to contact the ground operator to sign us up for an airplane de-icing. During taxi, it is a standard procedure to extend the flaps and also perform the flight control check. But all the checklists and all the standard procedures must be on hold until the de-icing of airplane is completed. This is because the contamination of snow and ice could potentially damage the flight controls. So, as we can see here, this is the de-icing and anti-icing procedure on ground. The checklist demands engine bleed 1 and 2 off, so does the APU bleed. The engine bleed system partly provides the bleed air for air conditioning system. Why does it need to be turned off? In case of some of the de-icing fluid, which is primarily propylene, and glycol-based fluid, which is primarily toxic, it could get sucked into the engine intake and end up in the passenger cabin. Therefore, we need to turn off the engine and APU bleed to reduce the chance of that happening. Ditching push button comes on to close all the exterior inlet and also the outside valves in case the plane ditches water. So to say, it is sealing the aircraft. The big outflow valve will be closed because we don't want any of the de-icing fluid running into the airplane. Once the checklist is completed, now we can start the spraying operation. The fluid spread onto the wing is also known as freezing point depression. These fluids are most effective when it is thermally heated and sprayed with high pressure. They will use different types of fluids as these fluids have different effects once they are applied to the airplane. The ground crew will inform the passenger in the cabin about the mixture and types, and also when the spraying operation has started. Passenger can open up the holdover timetable to see how long the application will be done until the takeoff.
Assalamualaikum and good morning. My name is Dainurul Izabiti Awangjuman and I will be presenting about the do's and don'ts in de-icing. So the first do's when you are de-icing an airplane is you have to make sure your angle is right. The right angle to spray the de-icing fluid is at an angle of 45 degrees or less to avoid spraying directly towards the surface. And the second one is when you are de-icing an airplane, you have to use the ground de-icing equipment to remove all the collected ice from the windows, windshield, and also its temperature sensors to avoid any damages that can cause towards the equipment. And the third one is when you are spraying the de-icing fluid, make sure to spray its wings and also its horizontal stabilizers from the leading edge to its trailing edge and from its wingtip to its wing roots. This is because since the wings are chambered, so by spraying it this way, the fluid can directly drain towards the middle part of the wings, which can save the fluid. The next one is the don'ts in de-icing, the things that you have to avoid when you are de-icing an airplane. So the first one is avoid spraying directly towards the windows and its windshield if necessary. This is because since de-icing uses a fluid which is the propanol glycol that is heated around a temperature of 140 to 150 degrees Fahrenheit, the high temperature can cause severe damages towards the equipment. And the second thing you have to avoid is you have to make sure the fluid doesn't go into the APU, which is the auxiliary power unit. It is a unit that allows the airplane to operate autonomously without reliance on support equipment such as ground power unit and also the external air conditioning. So when the de-icing fluid does flow into the APU, it can cause the APU speed to be out of control, and when this happens, it can cause serious injuries to the personnel and also towards the equipment. Next, I will be presenting about the differences between anti-icing and also de-icing. So the anti-icing is a system that helps to prevent the formation of ice on a certain part of the airplanes, while de-icing is a system that helps to remove all the ice that has formed on the airplanes. The next difference is anti-icing is a proactive application of melting products to driving or walking in airplanes before a storm, whereas de-icing is a reactive application of ice control products to driving or walking in airplanes to melt the existing snow and ice. So the third difference is anti-icing usually turned on before the flight enters icing conditions, while de-icing is usually used after a significant amount of ice that has built up on the airplanes. So the fourth one is anti-icing uses pneumatic or electrical methods to heat the area of concern, while de-icing uses diesel boots that vary the surfaces to break away formed ice. And the last difference is, an example of anti-icing is a heated leading edge with air, while de-icing is an inflatable boot on the leading edge.
There are 4 fluid types for standard aircraft de-icing and anti-icing. That are type 1, 2, 3, and 4. Type 1 fluids are the thinnest from the other fluids. They can be used on any types of aircraft. For example, they can blow off even at low speeds. They also have the shortest holdover times that being called as HOT or estimated times of protection in active frost or freezing precipitation. It is also provide very limited anti-icing protection. Next is type 2. This fluid add thickening agents to increase viscosity that designated to remain on the wings of an aircraft longer during ground operations, thereby providing anti-icing protection. The thickness remain on the aircraft longer to absorb and melt the freezing precipitation. This means to longer holdover times, but it also means a higher speed is needed to show off the fluid. This fluid should be used on aircraft with rotation speeds above 100 knots unless otherwise specified by the aircraft manufacturer. The Type 4 fluids meet the same fluid specification as these Type 2 fluids. Lastly, the Type 3 fleets. It also have thickening agents and have longer HOT than Type 1 fleets, but are designated to separate at lower speeds. They are designated for aircraft that have shorter time to rotation, and this should be make it acceptable for some aircraft that have a rotation speed of less than 100 knots unless otherwise specified by the aircraft manufacturer. In conclusion, de-icing of airplane is a process that prevents a build-up ice or snow on the airplanes. This de-icing or anti-icing must be done to every airplane because it can assure the passengers and the cabin crew safety. If it did not be done, it can cause a crash to the airplanes. It is because it can be a disturb to the airflow and can become a problem while the airplane did the takeoff. I think that's all from our group. Thank you for watching and bye.